Hi, my dear students. Welcome to ME Educational Institutions. Today, we are going to solve some problems based on mechanical properties of solids. Here, we need to discuss stress and strain calculations in the wire when the body of mass m is attached to it and the body is in horizontal circular motion. Here, we need to calculate stress strain calculations in the wire. So let's start the session. Stress strain calculations, we need to draw free body diagram for dynamic bodies. When the body is in motion, we need to draw free body diagram. Then we can apply D'Alembert's principle in order to calculate the force acting along the axis of the wire, that is tension in the wire. For that, we need to draw free body diagram. Have a look on the table. Free body diagram is nothing but it's a diagram which represents all the forces which are acting on the body. That is nothing but free body diagram. In order to draw free body diagram, you should know some fundamental points. See this, force is a vector quantity. It is having both magnitude and direction. So first we can have a look on the different forces which is studied in physics. Weight equal to mg. It is gravitational force. It always act vertically downward direction. Tension in the string always pull the body. Normal reaction at contact surface always act perpendicular to the surface. And here in this session, you will be focusing on centrifugal forces. Centrifugal force always act opposite to the direction of centripetal acceleration, that is radial acceleration. Radial acceleration always act towards the center of the circular motion. Centrifugal force always act opposite to the direction of centripetal acceleration. That is why centrifugal force always act away from the center of circular motion. We can discuss one by one. Here I want to discuss one more point. This is the point. Centrifugal force always act opposite to the direction of centripetal acceleration. Centripetal acceleration also called as radial acceleration. Radial acceleration always act towards the center of circular motion. Centrifugal force always act away from the center of circular motion. At every point of contact or surface, two normal reactions will be acting. Both are equal in magnitude and unlike in nature. A force which is acting away from the node assumed to be positive, that is tensile in nature. Pulling force means the force which is acting away from the node, pulling the node, that is tensile in nature. The force which is acting away from the node assumed to be positive. Frictional resistance and inertia force always act opposite to the direction of motion of the body. These are the forces corresponding magnitudes and corresponding direction of forces listed in the force table. You will be drawing free body diagram entire course by using the force table. We are having different forces. First, you should know the force table before going to draw free body diagram. Once you understand this force table, you will feel comfortable while drawing free body diagram for corresponding system. Now, I want to discuss one good question. What is the maximum angular velocity condition? When the angular velocity of the body will be maximum in this particular case? Just observe. Here, this is the maximum angular velocity condition. Here theta becomes equal to 90. Okay, maximum angular velocity condition means omega becomes equal to omega maximum. If angular velocity is maximum, here you will be getting R becomes equal to L. R becomes equal to L. Understood now? R equal to L. Here it is R equal to L. One of the important condition. So this part here it is acting like this. Understood? So here exactly support and it will go. Last time we discussed this case. If this is the theta is measured, theta becomes 90, it will go to horizontal position, then it is moving in the horizontal plane. This horizontal plane. Understood na? So in this manner, the body is in horizontal motion, and this condition is called maximum angular velocity condition. Maximum angular velocity condition. Here radius of circular motion of the body equal to length of the wire. Okay, so here I want to tell you at this condition R becomes equal to L. At this particular condition, radius of circular motion equivalents to length of the wire. Okay, here it is what? Omega equal to omega maximum, that is obtained at theta equal to 90 degrees. Okay, here it is what? R equal to L in the sense maximum angular velocity condition. Maximum angular velocity condition. Maximum angular velocity of the body. Understood na? So that is omega maximum angular velocity of the body. At that condition, these things will satisfy. Now, how to draw? This is the free body diagram. Weight acting downward direction, tension always pull the body, tension pulling this body, centrifugal force always act away from the center of rotation. Here you can call it as omega maximum. MR omega maximum square. Understood na? Here it would be this part, MR omega maximum square. Understood? Here we need to calculate, apply D'Alembert's principle. It's very simple. Sigma H equals to 0. Sum of the left forces equal to sum of the right forces. Tension in the string equals to centrifugal force, maximum centrifugal force, you will be getting maximum centrifugal force. Then I can confidently say that T equal to MR omega maximum whole square. Okay, so here what is the tension? Maximum tension. This is also maximum tension in the string. What is that? MR omega square. MR omega max square. Finally, tension in the string. At maximum angular velocity condition, tension in the string T equal to MR omega maximum angular velocity, This would be square. If you apply sigma v equal to 0, I want to tell you, in this case, sigma v equal to 0, if you are interested, sigma v equal to 0, mg equal to 0, m can't become 0, okay? Here g equal to 0, that means there is no effect of gravity. This g equal to 0, that means no effect of gravity, no effect of gravity in this particular case, no effect of gravity. Understood na? So acceleration due to gravity in this particular circular motion, horizontal circular motion, in this case theta equal to 90 at this particular condition. Okay, horizontal circular motion at this condition, no effect of gravity. At maximum angular velocity condition, I can write at W maximum condition that to horizontal circular motion. Understood na? So in this case, and for horizontal circular motion, no effect of gravity. It is one of the important relation for horizontal circular motion of the body here and maximum angular velocity condition. If you apply both the things, in both the things, then no effect of gravity, acceleration due to gravity equal to 0, tension in the string, mr omega maximum square. Last time we discussed what is the tension in the string, m omega square L. That is a regular case. In this maximum angular velocity condition, R becomes equal to L. Understood? Now we need to calculate stress strain calculations in the wire. Stress strain calculations in the wire. So I want to tell you this. This is the wire. Tension, tensile force is acting. Tension in the string acting as a tensile force. Stress strain calculations in the wire. So here I want to take D is the diameter of the wire. Diameter of the wire. Diameter of the wire. So I want to take this part as D, maybe capital D I can take. Capital D in order to avoid confusion. So here what is the tension in the string at maximum angular velocity condition? Tension in the string, m, r is the radius of circular motion, omega maximum square. So I can say that what is the, this would be A, this would be B. Stress sigma AB equal to load acting on the wire by area of cross section. What is the load acting on the wire? Tension in the string by area of cross section. A is the area of cross section. Finally, tensile stresses induced in the wire equivalents to, what is the tension? mr omega maximum square by A. This is the tensile stresses induced in the wire. Tensile stresses induced in the wire. Tensile stresses induced in the wire. Sigma AB equal to mr omega maximum square by A. Omega maximum is the maximum angular velocity of the body. A is nothing but circular cross section of the wire, pi d square by 4. If you are interested, you can substitute. What is the strain induced in the wire? Before going to that, what is the axial deformation in the wire? I want to write axial deformation in the wire. Axial deformation in the wire. What is the axial deformation in the wire? I can say delta L. Axial deformation in the wire. For that, we need to apply Hooke's law. Hooke's law is nothing but stress. This is directly proportional to strain induced in the member AB. Strain induced in the member AB. Here, sigma AB equal to Young's modulus of the material. This would be delta L by L. Okay. So stress induced, tensile stress induced in the wire AB. Okay. So this would be tension in the string by area of cross section. This would be E is the Young's modulus, delta L by L. This is the strain. So here I can say MR, omega maximum square by A equals to E times delta L by L. This is the strain. I can say that this would be strain in the wire, longitudinal strain in the wire. Understood now? This is the strain in the member AB or wire AB. So finally, what is the strain? Tell me. What is the strain? Strain in the wire equals to MR, omega maximum square by area into this area into Young's modulus. You can write it as Y also. E, you can write it as Y also. This is the Young's modulus of the material. Young's modulus of the material. Understood na? So here, what is delta L from here? Axial deformation in the wire. Axial deformation in the wire AB. Here you can write MR, omega maximum square into length of the wire by AE. R is equal to L here. This is axial deformation in the wire. Strain produced in the wire. This is strain produced in the wire. Strain produced. This is the longitudinal strain. Strain produced in the wire. Produced in the wire. Understood now? It is very simple. Stress induced in the wire and strain produced in the wire. Understood? MR omega maximum square by AE. E refers to Young's modulus. So if you are familiar to this, you can write like this. MR omega maximum square by A, and you can write it as Y also. Y and E both are Young's modulus of elasticity. Understood na? So this is stress, tensile stress induced in the wire. Sigma AB is the tensile stress induced in the wire. Epsilon AB is the strain produced in the wire. Delta L is the axial deformation in the wire. So these are the things people will ask in the exam. Okay. So this is the way to calculate. This is the way to do stress strain calculations in the wire when the body of mass M is attached to the wire and the body is in horizontal circular motion. and maximum angular velocity condition.